friends. So we're doing some review just to hopefully catch a little bit more of being able to do fraction math, because we all love fractions. So I'm just going to do a couple of these practice problems, maybe help out with story problems. There's two sides. We're just going to practice this today. We'll practice multiplication and division on Monday, or really the whole rest of what will be on the test. Okay, so when we're trying to add or subtract fractions, first thing we need is a common denominator. If we do not have a common denominator, then you want to ask yourself, can one of the numbers go into the other one? In this case, 6 can go into 18, so we only have to change this one to get a common denominator. So we need to multiply by 3, multiply by 3, and this becomes, the first one stays the same, plus 5 times 3 is 15, and 6 times 3 is the 18 that we want. So then you keep that same common denominator. It's still going to be your common denominator. And then you do the math on top. So 1 plus 15 is 16. And then those are both even, so I can divide them both by 2 to reduce, and we get 8/9. Okay? So you'll notice on number 2, 5 goes into 15, so we only have to multiply that fraction. Okay, this one's an interesting one, 16 and 12, because they share factors. Let's see, 32, I'm trying to think what the common denominator for that one will be. And so if you don't know what the common denominator is, this is when you list out their multiples and you find the first one that matches. So if we list out the powers of 16, we're going to have 16 and 32, and 32 plus 16 is going to be 48. Oop, and I know that that is 4 times 12. If we do the 12s, it's 12, 24, 36, and 48. So there we are. And that tells us how many, or what we need to multiply. 12 times 4, so this one we're going to multiply by, I say 4 and I write 5. I'm still doing it. Okay, 12 times 4, 12 times 4, and that'll be 16 times 3, and this is times 3. So we rewrite all of our fractions. 9 times 3 is 27. 3 times 16 is 48. Minus 5 times 4 is 20 over 48. Okay, and again, we just keep the same denominator. The denominator doesn't change. And then 27 minus 20 is 7. All right. Let's move on. We got a squinty face one here. Common denominator for 8 and 6 is going to be 24. Common denominator for 6 and 4 is going to be 12. Remember, when you have a whole number, you want to write that over 1. And then to get a common denominator, we want it to be 6, so we're going to multiply the top and the bottom by 6. So this one becomes 6/6 plus 1/6, which gets us the mixed number 7/6. Ha! I said 6 and I wrote 7. Come on, Stanford. Okay. All right, so that's what's happening on that side. For those things. Eye color. If 2/3 of the girls in a class have brown eyes and 1/4 of the girls have blue eyes, what fraction of the girls have neither blue or brown eyes? So what we're going to have to do is add these two fractions together and then subtract that from 1. So what that's going to look like is 2/3 plus 1/4. Common denominator is going to be 12. So multiply by 4s on that one, multiply by 3s on this one. So we got 8/12. A plus 3/12. 8 plus 3 is 11/12. So really we can just think about that now. If 11/12 of the class have blue or brown eyes, how many don't? And to get that to be, it's just going to be 1/12. Now, if you want to actually do the math on that, to write 1 as a fraction with 12 in the denominator is going to be 12/12. minus 11/12, and that gives us 1/12. Okay? Ubi made banana cream pie. His brother ate 1/3 of the pie, and his sister ate 2/5 of the pie. So this is going to be the same thing again. Add these two together, and then subtract it from 1. In this case, the 1's going to be 15/15. Okay? On the other side, we're going to be doing mixed numbers. And some of them already have common denominators, which is really nice. What's Sanford's rule for mixed numbers? I still want you to change them to improper fractions. The book doesn't force you to do that. I still think it works better, especially in a case like number 7, where in order to keep it there, you're going to have to borrow from your whole number to your fraction. And that seems frustrating to me. So I'll show you both ways. Okay? So looking at number 7, if we do it the book way, we need a common denominator first. So I'm going to multiply the top and the bottom of this one by 3. So we have 7 and 5/12 minus 3 and 9/12. But notice the 5 minus the 9 is going to get us negative, and that's not going to, I don't want to, that's bad. So we need to make this one an improper fraction. So we're going to borrow a 1 from the 7, and that becomes 6. Which means here, to add 1 with the denominator 12, it's going to be 12/12. So that one becomes 6 and 17/12 minus 3 and 9/12. And now we can do the whole number minus the whole number, which is 3, and 17 minus 9, which is 8/12. And then you need to reduce that. Now, Sanford's way is to just change everybody to improper fractions. So if we start from the common denominator place, so 7 and 5/12 minus 3 and 9/12. Now we're going to get some bigger numbers. So I'm going to run and grab a calculator because I don't have that many of my 12 times tables memorized. So we're going to do 7 times, it's 12 times 7, which is 84, plus the 5 is going to be 89/12. And then 12 times 3 is 36, plus 9 is 45. So I'm checking to make sure so I don't mental math this wrong. Okay, so common denominators. Now 89 minus 45, and you're welcome to do that on a calculator, is 44. So we end up with 44/12. And then 12 goes into 44. It's not quite up to 48. And so we're going to, 12 goes into 36 3 times. And 44 minus 36 gives us 8/12. And look at that. We ended up at 3 and 8/12 either way. So whichever way makes more sense to you. If we end up with negatives, the improper fractions will just work out a lot better. Okay, friends. If you need more help on this stuff, please watch the videos that are about these sections, and they can help you even more. Just reminding you, in geometry, like perimeter is the adding up the outside. So basically, you're just adding those 3 fractions. Not too bad on that. And then Natasha knitted 2 scarves for her dolls. One was 8 and 3/4 inches long. The other was 1.5 inches shorter than the first. How long was the second scarf? So it's 1.5 inches shorter than this, which means we're going to be doing 8 3/4 minus 1.5. Okay. We can common denominator this times 2 times 2. 8 3/4 minus 1 2/4. Now the subtracting will work the book way on this one. So you can do 8 minus 1, which is 7, and 3 minus 2 leaves us with 1/4. Okay, so on this one it works out okay, and it's not too bad. If we change them to improper fractions, 4 times 8 is 32, plus 3 is 35/4. And 4 times 1 is 4, plus 2 is 6/4. And that leaves us with 29/4. 4 goes into 28 7 times with 1 left over. So you get to the same place. And that's how that goes. So please, if you have more questions, let me know. If you need more review, go back to 4-4 and 4-5 lessons and watch those videos again. Okay, bye.